Hello and welcome to another video. In this problem we're going to be working on minimum penalty for a shop. So in this problem you're given the customer visit log of a shop represented by a string customers consisting of n and y, and if it is y that means the customer came at the ith hour, and if it's a no or an n that means the customer did not come. And so the shop can close anywhere from 0 to n, which is the length of the string, and there are penalties for this. So for every hour when the shop is open and no customers come, the penalty increases by 1. And then for every hour the shop is closed and customers come, the penalty increases by 1. And you want to return the earliest hour at which the shop must be closed to incur a minimum penalty. If the shop closes at the jth hour, it means the shop is closed at hour j. So for this first example, we are going to figure out what are the penalties here. And so if the shop closes at 0, that means it's closed this whole time. So for every y, there's going to be a penalty because the shop is closed and a customer came. So here, there's going to be a 3. If the shop closes at 1, that means for every time before the 1 that a customer did not come, we're going to get a penalty. And every time after a customer did come, we're going to get a penalty as well. So here, a customer did come, but it closes now, and so here customer did come, so we have a penalty. It did not, and then it did, so we have penalty 2. And then we have, so closing at hour 2. So what that's going to look like, so closing at hour 2 is going to be, that means it's closed here. So it was open, no penalty, and then here it was closed, and a customer didn't come, which is fine, and then here it was closed and a customer did come, so then we have penalty 1 as shown. And then closing at hour 3 means it closes right when you get here. So for all of this, it was closed for, so actually closing at hour 3 means it's closed at this index here. And so if it closes at this index here, that means it was open and a customer didn't come, so you get a penalty here. And then also it was closed and a customer did come, so you get a penalty here as well. So it's 1 plus 1 equals 2. And then finally, closing at the hour 4 means it was open the whole time. And so you would get a penalty for every time it was open and the customer didn't come, which would be here, which would be 1. And so for 2 and 1, our output is the same, but you want to return the earliest number, so it's going to be 2. And we are going to go into this more in depth. So in the second example, the customer doesn't come at every hour. So obviously the best time to close the shop is at 0, because every time the shop is open and no one comes, you get a penalty, so you just want to close it early. And then the last one is if the customer always comes, you just want to close it after the very end. So let's figure out how to do this problem. We're actually going to go back to this y, y, and y. Maybe we'll do like a few more. So let's just say it's like y, n, y, y, and y. So as you can see, you can get penalties from 2 things, right? 1, store was open and customer didn't come. And 2, store was closed and customer came, right? It makes sense. You don't want to be open when there's no one there, and you don't want to be closed when people are coming. So let's actually change this. And essentially, for this, our total penalty is just the sum of 1 and 2, right? It's 1 plus 2. So for everything, we can just say, like, if we're here, let's just get, like, it closed here. That means it's closed here. So we could figure out, like, what's the penalty for this side, and then what's the penalty for this side, right? But the problem is, we have to, like, for every number, if we just did that, that would be n time for every number, so that would be an n-squared solution. But if you look, let's see what happens for something like this, right? So the penalty for, let's just draw this out. The penalty for the store being closed is represented over here, or this is the thing you have to look at, and a penalty for the store being open is over here. But let's see what happens when these move, right? Let's see what happens. What about this store? Well, the penalty here, and let's just draw this in another color, for the store being open is over here, and the store being closed is over here. So you can see, like, these are almost the same, but now these just change. So you're literally just taking a value from here, right? You're taking a value from here, and you're just moving it over here. So we don't need to recalculate everything. We literally just need to update one value. So that's what we're going to be doing. And so our algorithm is going to involve, we're actually just going to calculate, we're going to start at the very end, and we're going to say, okay, what's the total penalty for the store closing at the very end? right? We're going to get some number, and then as we update, so at this point, all we need, like this, represents the store was open this whole time, right? So we actually close here, technically. Sorry about that. So we close here, and yeah, so we close here, and that means the store was open, and then there was no close period. And then as we move this to the left, we're just going to be taking one number from the open and then move it to the closed, right? So just to demonstrate that, so let's say we go from here, so that's going to be this, and then we go to here, and now we're going to have this and this. So we're essentially just taking one number from here and moving it here, and that's all we're going to be doing. So it's going to be a pretty straightforward algorithm. Essentially what we're going to calculate is what's the penalty for the store being open the whole time. So let's do that first. So what's the penalty for this store being open the whole time? So we're going to represent, we need two numbers, right? So we're going to have O for open and C for closed. So as you can see, since in the beginning it's going to close at the very end, we're just going to represent the penalty for the store being open the whole time, right? We're going to close, like if this is index 0, 1, 2, 3, 4, 5, 6. We're going to say the penalty closed, or the store closed at hour 6. And what's the penalty for the store being open all this time? Well, the penalty for being open is pretty straightforward, right? There's a penalty of 1 every time the store is open and someone didn't come, so that's 2 n's. So the penalty for the store being open that long would be 2, and the penalty for the store being closed would be 0 because there's nothing after it. And so this is what we're going to set to our initial result. So our initial result will be index 6, and our initial result count, let's call that, will be 2, right? It's going to be this plus this, right? We're adding them together to get a result. Okay, well now we're moving over here. So we're saying instead of closing at 6, we're closing at 5. So now all we did was just change this one store. Now this one thing is closed here. Well, what happens if it went from open to closed? Like, is that good or bad? Well, if it closed here, if you think about it, now we have a penalty, right? Because this was open before, but now it's closed. So this open penalty stays the same, but now we have a closed penalty because we're closed here, but we got a y. So now this will become 1, and now our count is 3. And so we want the smallest count possible, and we want the result to be the very most left value possible. So here our count is 3, so we're not going to want to update the result. Okay, we're going to keep going. We're going to say, okay, now let's say what happens if the store closes here. Well, now the store closed here, so now this penalty here subtracts because this used to be open, and you would get a penalty for a store being open and no one coming. So now from here, this would go down to 1, right? Because now we closed, and now this is fine. Like, this is better for us than it used to be. Like, this state is better for us than if it closed here. We want to be closed when no one comes. Okay, now let's keep going. So we're going to come over here, and we're going to say, what if we close here? Well, if we close here, then this used to be open, right? And now it's closed. So what penalty is that? Well, it's going to be the closed penalty, right? Because we're closed. And so we have a penalty that we're closed and someone came. So we're going to increase here. Oh, and by the way, so I forgot one thing. So here, this count is equal to this count, but then our index was 4, which is smaller than 6. So we're going to update that, right? Because we want the smallest possible index. So now here, we're going to say, okay, well, this used to be open and now it's closed. So this is the closed penalty. It's closed. And someone came, so we're going to update this. So now our count is 3, so we don't want to update the result. Now we're going to say over here, okay, this used to be open and now it's closed. So once again, we have a penalty because someone came. So this is going to be 3. And then here, this used to be open and now it's closed, but that's actually better for us, right? This used to be open and now it's closed, but so that's kind of what you're doing essentially. If it used to be open and now it's closed, if it's n, that's good for us, right? Then this open count goes down, so this will be 0. But if it used to be open and now it's closed and it's a y, then our closed penalty goes up. So we'll write that down though. Okay, so now we have count 3, and now here this used to be open and now it's closed, which is bad. So now this closed goes up to 4. And so let's write down our kind of the explanation for this. So number 1, calculate penalty for store being open the whole time and set that to initial values. Number 2, loop backward through string, and for every letter, if it's a Y, that means that the store was open and now it's closed. So we have a closed penalty +1, right? If it's a Y, the store was open and now it's closed. That's bad for us, right? Like we were taking in customers and now we're not. So that's bad for us. Okay. And if it's an N, that means that also the store was open and now it's closed, but that's good because we want it to be closed when no one comes. So we have open penalty -1. And then finally add open and closed penalties and minimize result. Right, so we just minimize result, we just add open and closed, we see what was our old result count, and if it's less than or equal to, obviously you do want to check for less than or equal to, because if the count's the same, you are going to want to take the leftmost index. And then finally you just return the result index over here, and that's your result. So a pretty straightforward algorithm, so we should be able to code it up now. So that's what we're going to do. So first we're going to start with getting the count of the store being open the whole time. You can loop this and you can just count up the number of n's. I'm just going to use a Python count. So we're going to say store open equals customers dot count n, right? So every time the store was open and no one came, that's a penalty. So we're just going to count the number of n's, and that's going to be the penalty for the store being open the whole time. And now we're going to set our default store closed to 0 because we're going to say it's open the whole time. We're going to set our initial result to the length of customers, meaning like here, our result will be 4, meaning like the store is just closed after everything. We're just going to start off with our initial thing with the result closing at the very end. Okay, and now res count is going to be store open here. Okay, and we are going to loop backwards. So for I in range customers, we're going to loop backwards, normal Python backwards loop. So remember, if customer I equals Y, that's bad for us, right? That means the store was open and now it's closed. So we're going to get a penalty there of store closed plus equals 1. You could also just store these in one value, like that would be fine as well. Maybe that's like a little bit better. So I guess let's do that, right? We can just have like a penalty variable. So let's do that. We can just combine store open and store closed into one penalty variable. So let's do that, and then we'll just say penalty. It's a little bit cleaner that way. So if, I don't know, I have counters, but if customers is Y, that means that's bad, right? That means the store was open and now it's closed, so we're going to incur a penalty there. So we're going to incur a penalty. Otherwise, if the store was closed and now we set it to close, now we're going to decrease our penalty because that's good, right? If the store was open on an N and now it's closed, that's good for us. So then we're going to subtract the penalty. And now simply for the result, it's pretty straightforward. So all we have to do is say if penalty is less than result count, whatever that variable is, less than or equal to, right? Because we're trying to minimize the index of the result. So on a tie, we would just want to take the smaller index. And since we're going right to left, it's always going to be the smaller index. We can just say result equals I and result count equals penalty. And finally, we can return the result, which should be our index. So let's give that a go. Customers. String is out of range. Oh yeah, this should be a length. Customers -1. We want to start the last index, which is customer -1. Oh, penalty. Misspelled. Keep going with errors. There we go. Alright, so you can see it's a reasonably efficient algorithm. I think there is like a way to do this in one pass, but either way, it's still going to be the same time complexity, so that doesn't really matter. So let's also do the let's do the time and space complexity here. So for the time, we are essentially looping through our customers forwards and then backwards. So that's O of n, right? This count will loop through it forwards. This will loop through it backwards. We're not storing any like arrays or anything. We just have a result variable, a result count variable, and a penalty variable. So for our space, it's going to be O of 1. And yeah, I think that's actually all for this problem. So hopefully you liked it. And if you did, then please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.